Right, we're on our last chemistry topic now, and it's entitled Paints and Pigments. It's quite a short one, and hopefully pretty easy for you guys. So, we just need to know what the components inside paint are. So, paint is made up of three things. There's the pigment, which is what gives the paint its colour. The binding medium, which is a polymer that binds the pigment to the surface that you're painting. And then you have your solvent, which is what dissolves the binding medium and makes the paint more fluid. So it's basically what makes it wet and means that you can paint it on. So those are our three components of paint. So the two types of paint that we need to know about are emulsions for the first one. An emulsion is a paint that is water-based, and after you paint it on, the water evaporates, and that's when it's dry and it just leaves the pigment behind. So in our emulsion, the pigment is carried in the water, we paint it on, the water evaporates when your paint dries and you're left with just the pigment behind. So that's an emulsion. Second sort is an oil-based paint. So in oil paints, the pigments are dispersed in oil instead of water, and sometimes that's then dissolved in another solvent just to make it easier to paint on. So same as with the emulsion, the solvent evaporates away and then the pigment and the oil just get left behind. Now, the oil then forms a layer over the top of the pigment because it reacts with the oxygen, and this protects the pigment, and it also gives it that distinctive look that you get with oil-based paints. So, both of these types of paints are colloids, and we've mentioned colloids before when we were looking at food. So, to remind you, in a colloid, we have particles of one substance that are dispersed amongst particles of another substance, but they are not dissolved in it. And the only reason they don't separate out is because the particles are so small that they just get spread amongst particles of the liquid that they're dissolved in. Well, they're not dissolved in, they are mixed with. So they're just spread out all the way between it. So, a couple things we need to know about. And we've all seen these before. We used them a couple lessons ago, so hopefully they're familiar. So I just want you to have a little think about what they do. And another thing you might have seen are these. So let's just have a little look at what's going on with these. I'm just going to point out the difference between this bit and this bit. I don't know if you'll have seen these before. They were very popular for a while, but I don't think many places keep doing them. But what do these two things have in common? That's the question. So what's the link? Well, our thermometers change colour as they get warm. So the bar that lights up is linked to the temperature. So the colour changes with the heat. And with the beer bottles, these ones and these ones here, it goes blue when it's at the optimum temperature to drink it. So when it's cold, it changes colour. So both of these things are types of pigment that change colour depending on the temperature. So we call these thermochromatic pigments. So thermo is telling us it's about temperature, and then the chrome tells us it is about colour. So thermochromatic pigments are sensitive to temperature, and they can be used for so many things, and they will change when the temperature goes up or when the temperature goes down. It just depends on which particular one you've picked, and they are very, very useful. You can also get a wide range of colours by mixing them with acrylic paints as well, so you get more colours out. So here's a different type of pigment. Hopefully you all know what's going on. They're glowing in the dark. So we call these phosphorescent pigments. So phosphorescent means that it gives out light. Basically they absorb energy and then give that energy out as light. So these pigments glow in the dark because they absorb light energy, store it, and then release it slowly over time. They're useful for watch faces, is the particularly common one, and fire exits, so emergency exit signs. So if the lights go out, you can still see how to get out. There's plenty in college, so I'm sure you can spot some around. But they are really, really useful. So the interesting thing about phosphorescent paints is that they've been around for quite a while, since about the 1950s actually, but the paints that we use now are completely different to the paints that we used back then. The very first glow-in-the-dark pigments contained radium. Now, I don't know if you know, but radium is highly radioactive. So these old watches, if you put them near a Geiger counter, so a radioactivity sensor, they are really radioactive, so they were actually really quite dangerous, and they were just sort of being given out to everyone as this awesome novelty. People even used to paint their teeth with the paint because it made them glow in the dark, because they didn't realise how dangerous it was. And it was all because it contained this radioactive pigment. However, now the current phosphorescent pigments that we use are completely safe. They have no radioactivity in them. So for those of you doing the hire, they may just throw in a question that asks you about how the paints are different now than they used to be. And the key thing is that we no longer use anything radioactive, which is why they are now safe to use. Okay, promised you it was short and sweet and hopefully fairly easy. So that is the end of chemistry. Next up is going to be your practical skills assessment. So let's get our heads around chemistry and then we'll have a go at some practicals.